All right, in this video, we're going to go over a couple examples involving geometric sequences. So for geometric sequences, we have two different rules. We have the explicit rule and we have the recursive rule. Remember, for us, the explicit rule is going to be our preferred rule because it helps us calculate terms of a sequence. Recursive rule is more of an important rule in computer science, but we still like to pay attention to it because it is such an important rule in computer science. For recursive and explicit rules, we're going to have to find two parameters. We're going to have to find the common ratio, and we're going to have to find the first term. So each sequence, we are going to be looking to fill in those two parameters of each of the rules. Common ratio is what we multiply each term by, and then the initial value is the first term in a sequence. And I have my calculator up here. You're going to want to have a calculator nearby when you're doing these problems because it's often helpful to find the common ratio by using a calculator. So they want me to first determine if the sequences are geometric. So that means I'm looking to see, is there a common ratio? How do I get from one term to the next? What is the pattern? And if it's multiplication, then the sequence is geometric. So it looks like my pattern here is that I'm adding 2 each time, plus 2, plus 2, plus 2. So this one is not geometric. Let me change my marker. This one is not geometric. It is arithmetic. Number 3, however, if I ask myself, how am I getting from 32 to 16, from 16 to 8, from 8 to 4, I'm getting half as big each time. I'm multiplying by a half over and over. So this one is geometric because the common ratio is 1/2. So for the next one, they say find the common ratio and then write the next 3 terms. So for 5, I'm trying to see what is the pattern. How did I get from -6 to +12, then from +12 to -24, and then from -24 to +48? Anytime the sequence alternates, negative, positive, that means my ratio had to be negative. So I'm multiplying by -2 each time. So that tells me R is -2. Then to find the next 3 terms, this is why having a calculator is handy. I'm going to multiply 48 by -2. So -96 is next. Then I'm going to do -96 times 2. Oops, sorry, -96 times -2, which is +192. And then I'm going to do 192 times -2, which is -384. For the next one, 1/4 to a half, 1/2 to 1, 1 to 2 looks like a pattern of 2 as my common ratio that I'm doubling each time. So my next 3 terms, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So number 9 has me filling in the explicit rule. So I'm filling in the parameters of the explicit rule to find the 8th term. So that means that I'm going to plug in a sub 1. So if I look up at my explicit rule, a sub 1 is what goes in the first blank. So that's -4. Then R goes inside of the parentheses. That's 3. And I'm finding the 8th term. So that's what gets plugged in for n. So just to write it a little bit clearer, I'm doing -4 times 3 to the 8 minus 1 to find the 8th term of the sequence. So let's use Desmos. -4 times 3 to the 8 minus 1. Let's use that. 8 minus 1. Actually, in the exponent, let's just do 7. 8 minus 1 is 7. So the 8th term of the sequence is -8,748. All right, let's take a look at a couple more examples. All right, I'm going to do number 11. So they want me to find the 9th term of the sequence. That means I'm going to use the explicit rule. We always use the explicit rule to calculate terms of the sequence. So my formula is a sub n equals a sub 1 times r to the n minus 1 power. So since I know that the first term is -3 and the common ratio is -2, my explicit rule is going to be -3 times -2 to the n minus 1 power. So to find the 9th term of the sequence, I'm going to do -3 times -2 to the 9 minus 1 power. So in Desmos, let's type -3 times -2. 9 minus 1 is 8 to the 8th power. So the 9th term of this sequence is -768. Number 13 wants me to find the 8th term. So again, I need to write an explicit rule. So I need to know my two parameters. I need to know a sub 1, which is 243. And then I'm getting a third as big each time. I'm dividing by 3. So r is 1/3. 243 times a third is 81. 81 times a third is 27. 27 times a third is 9. If you're not sure, what you can do is do 81 divided by 243. And if you click this button, it'll convert it to a fraction. So my common ratio is 1/3. If you're unsure of what the ratio is, you do the number divided by what came before it to know what you multiplied by. So 81 divided by 243 is 1/3. So a sub n equals 243 times 1/3 to the n minus 1 power. So to find the 8th term, I'm going to do 243 times 1/3 to the 8 minus 1 power. So let's see what that is. 243 times 1/3 to the 7th power. And let's convert this to a fraction. So that's going to be 1/9. So the 8th term of the sequence is 1/9. All right, and then we've got a word problem. So Martin has a job and he starts with $8 per hour. And then each year he's going to get a raise. The table's showing his raise for the first few years. Let's find his hourly wage after 6 years. So the first term, a sub 1, is $8. That's what he started with. To find the common ratio, I honestly don't know what I multiplied 8 by to get $9.60. So same thing I did before, divide by what came before it. So 960 divided by 8 that came before it is a common ratio of 1.2. Which makes sense because if I did 8 times 1.2, I would get 960. So if you need to know the common ratio, divide by what came before it. So to find the 6th term, I'm going to do a sub 6 equals 8 times 1.2 to the 6 minus 1 power. So 8 times 1.2 to the 5th power. And they want us to write it as to the nearest cent. So it's going to be $19.91 is how much money he's going to have after working for 6 years.